Hi everyone. We're going to solve a limiting reactant or limiting reagent problem in this video, and these are the properties of the limiting reactant. And let's see if we could try to understand these properties maybe with a more realistic example, an example that we've all experienced before, making a sandwich. So for every one piece of cheese, I'm going to need 2 slices of bread, and I can make one sandwich. So if I tell you that I had 3 slices of cheese and 4 pieces of bread, automatically you would know that you can only make 2 sandwiches. And you know that bread would be the limiting reactant and that cheese would be the excess reactant. So are these properties true? Yes, the bread determined the amount of sandwiches that we can make. And yes, the bread determined the amount of cheese that we used. And yes, the bread will get used up in the reaction, as you see here. So with this little background in mind, let's try a chemistry problem. And here it is. You may recognize this reaction as the Haber process, and they're telling us that we have 1.5 moles of nitrogen and 2.5 moles of hydrogen. They go to a reaction vessel, and they want to know how many moles of ammonia are produced, what is the limiting reactant, and how many moles of the excess reactant are left over. So I recommend a 3-step process to solving these problems. First of all, do I use the nitrogen to determine how much ammonia is formed, or do I use the hydrogen? In other words, which one is the cheese and which one is the bread? Which one is the limiting reactant? So that is the first step. Determine the limiting reactant. And I have 2 different ways that you can do that. The way that I do it is I want to know which reactant is it, the hydrogen or the nitrogen, yields less product. Well, let's see. If we have 1.5 moles of nitrogen, and for every 1 mole of nitrogen, I'm going to make 2 moles of ammonia. That means I could make 3 moles of ammonia if nitrogen is the limiting reactant. Let's try the same thing with the hydrogen. We have 2.5 moles of hydrogen, and we see that for every 3 moles of hydrogen, we're going to make 2 moles of ammonia. So that's only 1.7 moles of ammonia. The reactant that yields less product, in this case it was hydrogen, is the limiting reactant. So hydrogen is the limiting reactant, nitrogen is the excess reactant. This is absurd, and we've kind of answered 2 questions in one step. How many moles of ammonia are produced? That's right here. And what is the limiting reactant? That is hydrogen. And I always like to label it in my reaction. Let's go back to the sandwich example. So it's obvious here that bread is the limiting reactant, but using the method that we used before, which reactant yields less product? For every 3 pieces of cheese, I can make 3 sandwiches. But for every 2 pieces of bread, I can only make 1 sandwich. So here, with 4 pieces of bread, I can only make 2 sandwiches. So that means that bread is the limiting reactant. Let's go back to the chemistry problem. The other way that you can determine the limiting reactant is to kind of ask yourself, do I have enough reactant? Do I have enough reactants? So let's see. Let's start with this 1.5 moles of nitrogen. And do I have enough reactant? Well, for every 1 mole of nitrogen, I'm going to need 3 moles of hydrogen. So that means that I'm going to need 4.5 moles of hydrogen, but only 2.5 moles are present. You need 4.5, you only have 2.5. That means that hydrogen is the limiting reactant and nitrogen is the excess reactant. Let's go back to that sandwich example and see if this makes sense. So here we go. Do I have enough reactant? Well, I have 3 pieces of cheese. And I know that for every 1 piece of cheese, I'm going to need 2 slices of bread. That means that I would need 6 slices of bread, but I only have 4. Again, bread was the limiting reactant. Let's go back to the chemistry example. So hopefully one of these ways makes sense to you. Again, I usually choose or use this method because it helps me to identify the limiting reactant and it tells me how much product is formed. We still have one more question to answer. How many moles of the excess reactant, well, in other words, nitrogen, how many moles of nitrogen are left over? So step 2 is to determine the amount of excess reactant reacted. And here we're going to start with the limiting reactant. And remember, that was hydrogen. Remember, the limiting reactant determines the amount of excess reactant used. So start with the limiting reactant, that is hydrogen. So we have 2.5 moles of hydrogen. And we know that for every 3 moles of hydrogen, we're going to use 1 mole of nitrogen. So it looks like we've used 0.833 moles of nitrogen used or reacted, whatever word you want to use. And then the final step is to get the excess reactant left over, and that's what we're wanting. We're going to take the initial moles of excess reactant. That's this. This is the initial minus the moles of excess reactant that got used. That's this. And the difference is what we have left over. And I'm only going to need 1 decimal place, right? So I'm getting 0.67 moles of nitrogen left, or I would round that to 0.7 moles of nitrogen left. Again, that was our excess reactant. So it's going to take a lot of practice to get comfortable with these types of problems, but I assigned a lot of homework, so keep on practicing. Thanks for listening and good luck.